Hi, this is Cynthia with Mark and Shelley from the Center for Mathematics and Teaching. Thank you for joining us, and we look forward to discussing our new second edition MathLinks core that will be available for purchase this fall. So let's get started on statistics and probability. As our goals today, we're going to focus on some important middle school probability and statistics standards from interesting, engaging lessons. After seeing them, we think you'll want to try some of them in your school. The ideas we'll be sharing with you today are taken from our second edition of our MathLinks courses. Here you see 3 units per grade level that are ready to try. We call each of these units a packet because they are offered in a consumable packet format. You'll see that they are much more than what people think of as a workbook. So stay tuned for examples. The full 10 packet course will be available this upcoming school year. Here are the packets we shared in a webinar a few weeks back. These are all about using multiple representations to gather data in tables, make graphs, and write equations. Sort of the basics of linear equations relevant to grades 6, 7, and 8. Those webinars are available to view on our website, and you can also find those packets on our website to try. We'll share with how to do that in a bit. These packets address most of the middle school geometry as we looked at yesterday and will be posted on our website soon. And here are the 3 statistics and probability packets we'll be looking at today. Remember that new MathLinks programs are complete, cohesive, core programs that are student and teacher friendly and efficient to use. Here you see the scope and sequence for 6th grade. The lessons in just 10 student packets allow you to address all grade level standards in only 100 class hours, leaving plenty of time to do other important work. Here is packet 7, which we addressed previously, and packet 9 we looked at yesterday, and packet 1, which we'll be looking at today. Here is a 7th grade course with packets 3 that we looked at before and packet 9 regarding geometry and packet 1 that we'll be experiencing today. And finally, the 8th grade course with packet 4 and packet 1 that were looked at previously and packet 6 that we'll see today. Remember that all 9 of these packets are available to pilot. This is what the consumable student packet looks like. And if you pilot, you'll be receiving these to use with your students. All right, let's begin with 6th grade statistics pilot packet. Mark, take it away.
We're going to take a look at some highlights from lessons 1 and 2. We hit the ground running in the 6th grade course with a super engaging introduction to statistical measures and data analysis. Name scores starts with letter values similar to popular word games. After a quick example, students write their name score on a sticky note. Then they figure out how to line up in order. Doing the activity means that they're directed to identify their peers in line to hold cards to represent the following: the minimum, the maximum, the median, each of the quartiles. And even though range comes up, we realize that this measure of spread isn't any single person's data point. Then students reconfigure into sort of a bar graph where we identify the mode. And that's about as far as we take it for now. We realize that many students are not familiar with this new vocabulary yet, but some may be, and it's a great physical and visual introduction for many of them. By the way, students are not writing at this point, and so after we've completed this lining up part, students go back to their seats and start to fill in their packets. To continue, probably on the 2nd or 3rd day of instruction, we get back up and everyone takes some small objects, a number of objects that's equal to their name score. All you need is something plentiful, like pennies or paper clips. It really doesn't matter. We're going to do our example with these small cubes. Then students are instructed to share equally. Take a look at this visual to see how it could play out. It takes a bit of time until the objects are all shared appropriately, namely, so that everyone has the exact same number of cubes, if possible, or if not possible, no one differs by more than one cube. Though students probably don't know it, what they've done is estimating the class mean, or average, name score. While at their seats, students compute the actual mean after seeing this example. And then we introduce a silly name with a huge name score so we can talk about what it means for a data point to be an outlier. What you've seen is only parts of 2 lessons that take a few class hours each to complete. As with many lessons, you'll be able to use the slide decks provided to guide instruction if you like. These come with concise notes for the teacher. They're not a script, but give you an idea on how to pace this part of the lesson and offer some good questions we think should be asked. Additionally, if you prefer some other delivery method than a slide deck, this alternative page is provided to use on a DocCam or for writing on a whiteboard or using a smartboard or whatever your preferred style is. And every concept development piece in the packet is always followed up with some practice. And all the practice pages, like all the pages in our packet, have plenty of inviting workspace. There's so much more going on in this packet, and we hope you will want to experience it all at your own pace at another time. Okay, let's take a look at some of the 7th grade probability pilot packet. This time, we'll take a peek at the opening problem and see how it's followed up later in the 2nd lesson. This is a common feature of MathLinks packets. Pose a problem at the start where students can engage with the problem, but almost surely can't complete it. Then we do some teaching and learning, and we eventually revisit it when students have attained concepts and skills that they can put to use. Race to the Top is a simple number cube game where students record sums on dice and see which sum wins by getting to the top of the chart first. This is what the page looks like in the student packet where they record their sums. Getting to the top of the chart signifies the winning sum. We discuss the results and try to make predictions and start the process of more formally studying probability. Eventually, we begin to formalize the common probability vocabulary, notations, and representations. Students learn how to organize data in tree diagrams and outcome grids so that they can analyze data using theoretical probabilities. And after plenty of concept development and practice, we have what we need to revisit the opening problem and draw some conclusions. There's plenty more to see in this packet, and you can see it at your leisure another time. Now, on to the 8th grade statistics pilot packet. In 8th grade, we depart from single variable statistics and learn about bivariate statistics. Here, we'll look at parts of the first 2 lessons. In some cases, we like to use real data for exploration. This shows different levels of education and corresponding income and unemployment data.
Are you going to redo 36 also?
No. I think I was okay with 36.
36 was fine, I thought.
Yeah. I'm just okay. Okay, I'm going to start here.
Okay, take whatever for 37.
All right. We discuss linear associations and give examples later of associations that are not linear, or data points that cluster so that the variables appear not to be associated. And, as usual, students practice the concepts introduced. In the second lesson, we come back to the same education data to push the thinking further. As a median is a measure of center of a single variable data set, in some sense, a line can be a measure of center of an associated bivariate data set. And so here we move forward with estimating lines of best fit. This is a nice slide to discuss this new idea. Visually, what makes a good line of best fit? And then we practice. And before leaving this packet, let's take a very quick sneak peek at the last lesson on categorical data. Here's a two-way table. So there's a new representation and new vocabulary to learn. As you're watching, what do you think this data might be about? To find out, you'll have to look at the lesson yourself. For a problem-solving example, I wanted to share this page with you. Students analyzed some data about phone buying habits of people in different age groups. But what I want to point out to you is our MathLinks rubric, which is a routine we think is great to establish in your classrooms. Within packets, there are a few rubric-worthy problems, as we call them, and we can use these in conjunction with the rubric to help students become better problem solvers. By taking a page like this, or some subset of problems on the page, you can facilitate self and peer reflection opportunities with your students. This kind of formative assessment really helps students to examine more closely what it is to solve problems more thoroughly. We also offer extra tasks so that these kinds of problems can be used as more summative assessments as well. Why wait until higher stakes tests to see if your students can effectively tackle performance tasks? Whenever we share our lesson ideas and the simple, effective format we use, people really seem to like what they see. We hope you do too. And now back to you, Cynthia.
Thank you, Mark. If you're ready to look further, go to our website that you see here, mathandteaching.org, and find the curriculum tab, where you'll see our new core second edition. There, you'll find everything you need to know about piloting one of our statistics or probability packets that you experienced here, or any of the 9 packets that are ready for piloting. If you're not quite ready to pilot, this link here will take you to a place where you could preview 3 packets, 1 from each grade level, which allows you to get a view of the whole packet and even try some of it. When you choose to pilot, here's what you'll get: a class set of consumable student packets, access to all teacher materials, and virtual support from one of us to get you started and work with you as needed. Now let's move on to some student packet features. Focusing on vocabulary is important in learning mathematics. Every packet begins with a word bank. As vocabulary comes up in context, teachers facilitate student discussions so that they can include meaningful examples and explanations in their own words. In the review section is a vocabulary activity for practice. The review section has 3 pages of review activities, many of which are best done with partners. The example shown here is a match and compare sort, where students first work individually to match some words to their explanations. Then pairs put their heads together, comparing and contrasting each of their sets of words. Also, here's a why doesn't it belong? A new take on an old Sesame Street, one of these things is not like the other. Or more recently, the which one doesn't belong, but with our own spin on it. Every packet has a few spiral review pages, so students can strategically revisit important topics from previous packets throughout the year. Here you'll actually notice that our algebra review is set into a puzzle format. Near the end of every packet is a page dedicated to reflecting on the content and mathematical practice of the packet. At the top, you see the 8th grade Big Idea wheel. In the bivariate data packet, 3 of these big ideas of the grade are addressed, with connections made between them. Along the way, we prompt teachers to consider particular problems suited for journaling, and at the end of every lesson, we ask students to go back to the packet cover and score themselves on a scale of 0 to 3 on what they've learned. Then at the very end of the packet are precise definitions and explanations and examples that students and those who might be helping at home can refer to. Now for a quick overview of some teacher resources. We know that assessment is important, so we want to provide several options for multiple measures with which to assess students both formatively and summatively. Here you see a wide variety of what we consider to be a formative assessment, many within the student packet. And here you see what are more commonly considered summative assessments. Lots of variety and lots of choice. And of course, there are a wide range of needs for different learners. While we can't possibly begin to address every possible learning difference, we do provide many ongoing opportunities for differentiation. These features that are based on intervention research address the needs of struggling learners and give them a better shot at doing grade level work. All students deserve opportunities to show what they can do, so these features are meant for all students. Know that when some students are working on catching up, some of these features are great for other students who are ready for enrichment. Here is a close-up view of our grade 8 Big Idea wheel that is in the teacher edition. We are convinced that teaching with an eye on big ideas allows for more connections to be made and more efficient and effective learning. Think about the benefit of making connections using big ideas. Since the lessons in the 10 packets are designed to address all grade level standards in about 100 class hours, we know that the remaining time can be split up with extra practice, intervention, enrichment, and assessment, all of which are right there at your fingertips. So to wrap things up, I would like you to take a look at any of these links provided for more information on our core 2nd edition, how you might possibly pilot, or to view some of our past webinars. Thank you so much for attending. Have a great day.